To work with domain and range in interval notation, we first need to talk about what interval notation is. So if you are already familiar with interval notation, then you might want to skip ahead to where the questions begin with domain and range. We're going to do a lot of talking here about what this is theoretically. All right. So in interval notation, we use parentheses if values are not included, often represented by an open circle on a graph. So if we see an open circle, it means we are not including that value. These intervals can also be written with less than and greater than symbols. So if something is not included, we will use these. Okay. Open circle, those less than or greater than symbols, and parentheses are all synonymous. Similarly, we use brackets if values are included, often represented by closed circles. These intervals can be written with less than or equal to or greater than or equal to signs. So the equal to determines whether it is included or not. Okay. And so if we do not have those equal to lines, less than or greater than, then they are not included. Parentheses are always used for infinities because we don't actually attain infinity. We sort of go in that direction. It's kind of like going west. You can never actually get to west. You can just go that way. So that's what infinity is. So infinity is often represented by arrows at the end of a curve or line, meaning that it continues on indefinitely. So the open interval, a from a to b, represents the set of real numbers between but not including A and B. And then we have the parentheses there, and that is, if you notice, these match up. There are less than symbols there. So this shows all the x values that are between A and B, not including A and B. However, the closed interval, bracket AB, represents the set of real numbers between and including A and B. So if you have two sets of brackets, that indicates we have two less than or equal to symbols in that case. Now an infinite interval from a number a to infinity represents all the numbers that are greater than a. And so that would be number comma infinity. We of course have a parenthesis on the infinity end of that, and we also have a parenthesis on this end because we are greater than but not equal to a. Now, the infinite interval from negative infinity to b represents numbers that are less than or equal to b. These can both be switched to represent something else. But we have a less than or equal to, so we have a bracket. We have an infinity, so we always have a parenthesis. Parentheses indicate endpoints that are not included. Square brackets indicate endpoints that are included. Parentheses are always used with infinity or minus infinity because, as I said earlier, you can't actually get to infinity. You can't attain or include infinity. Now we'll look at domain and range of a function from its graph. This function right here, and it is a function because it passes the vertical line test, this function extends in the x direction, the input direction, from -2 to +1. It does not actually get to -2. It's an open circle. That point is not included. But it does actually get to the value 1 because that is a closed circle. Therefore, we have a parentheses, -2, comma 1 bracket. Again, those inequality symbols line up with that. So that's looking in the x direction because it's domain. For the range, we look in the output at the outputs, the y-axis. The lowest in this case this function gets is -1, and it gets there. It's a solid closed circle. So we have a bracket, -1, and the highest, the largest value this function attains is +2. But it doesn't actually attain to, it just gets close to it. It's open. So we go to value 2 and close parentheses. Now let's look at a few that are not already answered for us. Find the domain and range of each graph below. Write in interval notation and with inequalities. All right, so we want to look at this as going in the x direction first for domain. Domain, looking furthest to the left, it appears to get to 1, 2, 3, the value 3 in the x direction. and it actually does get to that point, so I'm going to put a bracket there. Now to the right appears to be positive 3, and it does get there because we have a closed dot. So our domain is negative 3 to 3, and that's a closed interval because we have two closed dots. Now, as an inequality, if x such that negative 3 is less than or equal to x, it's less than or equal to 3. Now for our range, the lowest our function gets is minus 5, it appears. Okay, so we have minus 5, and that is equal to, we have two closed dots there. So we have bracket, and then the highest function gets is up here at 4. And we don't have an open dot there, so we assume that that's closed. So it goes from negative 5 to 4. And that would be written as y such that negative 5 is less than or equal to y is less than or equal to 4. And we'll close our brace there. That's it in inequality notation. We didn't have any open dots in that, so there are no parentheses at all. Now on this second one, we do have an open dot on one end, so we will have parentheses. So our domain on the left, furthest left this gets appears to be minus 5. Minus 5, and the furthest to the right is positive 5, but it is a parenthesis because we have an open dot there. So that would go minus 5 less than or equal to x. Oh, that's the inequality. Let's go with the bracket first. Minus 5 to positive 5 parenthesis. That would be x such that minus 5 is less than or equal to x is less than 5. Now our range, looking at our output values, the lowest this function gets is minus 10, and it is included. And the highest, the maximum value, is minus 4. And that is not a bracket because it is an open dot at that point over there. So we would have bracket minus 10, comma minus 4, parenthesis. This would be y such that minus 10 is less than or equal to y is less than minus 4. And there we have the domain and range in interval and inequality form. Let's look at another example. Find the domain and range of the functions using the graph. Write in interval notation and with inequalities. Well, this function, the domain begins at minus 4, that's the furthest to the left, and it is attained, it's included there, but it does not cease going to the right. Okay, so we are going to use positive infinity with a parenthesis, of course. So we would say this is the x such that x is greater than or equal to minus 4. Now the range, the lowest this function gets is 0, so we would include 0, and it continues increasing forever, so close parentheses, and this would be y such that y is greater than or equal to 0. Next function, our domain. See, the furthest to the left this gets, actually it doesn't stop going to the right or to the left. So this is minus infinity and positive infinity. So we would write it like this: x such that x is a real number. X such that x is a real number, which means it continues forever. There is no point where it's not in the domain. And our range, well, the lowest point this gets is minus 1, and it increases indefinitely. So this would be y such that y is greater than or equal to -1. Our last example is going to be find the domain and range of these functions. Well, the first actually continues going to the left, continues going to the left, continues going to the right. Okay, so the domain is -infinity to +infinity, and I'm not going to write this in interval in an inequality notation, since that's all real numbers. And actually, I'm going to go ahead and write this. This little symbol with an R actually indicates all real numbers, which is -infinity to infinity. All right. The range, it doesn't get to a lowest point or a highest point. So this one is also -infinity to infinity, or all real numbers. All right. Our last graph, going left, going right. It does not stop. But there is a lowest point. The lowest point is -4 going to infinity. And this would be y such that y is greater than or equal to -4. And you can see that from the graph as well. It is all great. The function is greater than -4. All right, and that